Okay, me again. I hope you liked my first video. So I'm here again for my second video. In first video we talked about traditional safety stock methods and we discussed how to calculate the safety stock. In that method we used standard deviation of historical demand to capture the demand variability or fluctuation in demand in the safety stock formula. Let's go one step further. In reality, future demand may or may not follow historical demand pattern, right? So in that case, forecast accuracy may not be 100%. You will have some forecast error. So in the literature, people also use another method. So they use standard deviation of forecast error instead of standard deviation of historical demand. So both methods have their limitations. In this video we'll discuss those scenarios and we'll talk about the comparison of those two methods. So let's get started. Okay, I hope I'm sharing my screen. In my first video, I talked about traditional safety stock formula. In this video, we will evaluate this method to see how good it works in different settings. For example, when data does not have a trend, and second, when data has a trend. We will discuss 4 cases with numerical examples. Okay, as you can see in your screen, this formula, equation 1, the same formula that we discussed in my first video. Only thing is I'm using k instead of z, so no difference. Still you need to look into a z or normal distribution table against your customer service level. So one thing you need to be very careful when you select a customer service level, because the higher the level you are using, the more safety stock you need to carry. Okay, so in many cases you might not want very high amount of safety stock, right? Totally depends upon your inventory. Okay, so the one thing to control is this customer service level. Okay, sometimes you have direction from your management how much customer service level you would be keeping, and if there is not, then you need to use your instinct or your understanding of your data and the industry. Okay, so totally depends on you how you are using it. Okay, so we call this formula demand system as well. Okay, beside the traditional safety stock formula. So in this formula we assume that demand follows normal distribution. Okay, and also there is a second method which we call forecast system, which is also used in the literature. In that method we use standard deviation of forecast error instead of standard deviation of demand, as you can see in equation 2. Okay, there is no change, only we are replacing standard deviation of demand with standard deviation of forecast error. Okay, and also we assume that forecast error follows normal distribution. So if whether this assumption is true or not, that's another debate. Okay, we will be talking more about normal distribution assumption in my future videos. Okay, for this video let's assume that our demand and forecast error data follows normal distribution. Also, one more assumption we are making here is the lead time is constant, because we just want to focus on the demand side. Okay, so we just want to evaluate how this formula works when demand has a trend or does not have a trend. So it won't make much difference if we use lead time as constant. It will just help us in doing analysis. Okay, so let's have some model assessment here. I'm using 2 periods, period 1 and period 2. Each period has 5 weeks, and week 1, yeah, so week 1 through week 5 is period 1, week 6 to week 10 is period 1. Okay, this also suggests that lead time for that part or component is 5 weeks, is constant. Okay, look into this equation number 3. This tells you how much inventory you should be keeping for any given period of time, the minimum inventory. So the minimum inventory for any given period of time, you should be able to support your demand for that period, for example LTD2, and also you carry some additional stock which we call safety stock to respond on those cases where we see some demand fluctuations, demand upsides, or supply issues. Okay, so we don't face any stock outs. Okay, so I'm rewriting this safety stock formula here. I'm using 1 arrow 2 because we are trying to calculate safety stock for period 2 while we are still in period 1. Okay, we assume that we are sitting in at the end of week 5 and we are trying to calculate for the period 2, safety stock for period 2. So in real world, this really happens in the real world as well. So because in real world you also calculate safety stock for next period or the following period while you are sitting in the current period. Okay, because you do not know the demand for the same period for which you are calculating safety stock. Okay, so you have to calculate safety stock well ahead of time so that you can plan and place orders to your suppliers because they have their lead time as well. Okay, if you try to calculate safety stock for the same period, okay, that might be too late for you. So we have to make some room when we calculate some safety stock. Okay, okay, then you can write total inventory formula as well, 1 arrow 2 demand system, and safety stock formula here as well. So let's move on to discuss 4 cases. In case number 1, mean of demand for period 1 and period 2 is constant. Standard deviation of demand is going up in period 2. In other words, there is no trend in the data. So data is stationary in period 1 and period 2. Only thing is a standard deviation of demand is going up in period 2, meaning that you have demand fluctuation more in period 2 than period 1. So mathematically you can write LTD2 equals LTD1, sigma 2 greater than sigma 1, standard deviation of period 2 is greater than standard deviation of period 1, or you can write sigma 2 equals sigma 1 plus delta S because sigma 2 is higher. Okay, so now you can write inventory equation the same way that I showed you, and LTD2 equals LTD1, so you can replace LTD1 with LTD2 here, and then you see in the bracket inventory for period 2 that you calculate for period 1 is greater than demand for period 2. Okay, because left hand side would be greater because there are 2 factors here in the right hand side. Okay, it's very simple math. Let's have some numerical example. Period 1, we have some demand for period 1 and we have some demand for period 2 as well, and we have set some hypothesis. The null hypothesis says the target inventory under demand system is sufficient to support demand for period 2. So in other words, your inventory should be enough to support at least demand for period 2 that you are calculating. So the rejection limit would be LTD2 is higher than inventory for that period, meaning that if your inventory that you calculate for period 2 is not enough to support demand for that period, then the null hypothesis has to be rejected. In that case, you need to carry more safety stock. Okay, let's put numbers here. You calculate LTD1 90, you put numbers here, you get LTD2 is equal to 90 as well. You have standard deviation for period 1 is 4, standard deviation for period 2 is 6.782. Then you put in the safety stock formula, you get 20.804. You are using K as when you go and check normal table, you get value of k is 2.326 against the service level of 99%. Okay, so here in this example I'm using customer service level of 99%. It's not a hard and fast rule. It totally depends on your data and how much you want to set your customer service level, like I told you in the beginning of this video. Okay, and then you put in the total inventory formula, you put LTD1 value 90 and safety stock value here as well. So your total inventory that you calculate in period 1 for period 2 is 110. That is higher than your demand for period 2. So this means that you fail to reject the null hypothesis and learn that your inventory for period 2 that you calculate in period 1 is enough to support demand for period 1 at period 2 at least. Okay, so let's move on to case 2. The case 2 says mean of demand and standard deviation for period 1 and period 2 is constant, meaning that your data is stationary, there is no trend in the data, and also the fluctuation in period 1 and period 2 are constant, fluctuation of demand. Okay, LTD2 equals LTD1, sigma 2 equals sigma 1. That's mathematical equations. Okay, and then so let's have some numerical example here. You have values for demand week 1 through week 10, and you put you have same hypothesis settings here, same rejection limit. Not gonna go over again. Okay, you put the values here, you get LTD1 75, you get LTD2 75, you get sigma 1 equals sigma 2 because fluctuations are constant in period 1 and period 2. So you put in the safety stock formula, you get 23.259. So when you put in the total inventory formula, you get total inventory 98.25. It's still higher than demand for period 2. So meaning that your inventory is enough to support at least demand for period 2. Okay, so we fail to reject the null hypothesis, as you see here. Fail to reject. Sorry. Yeah. Case 3. In case 3 says mean of demand is going up, standard deviation of demand is constant. In other words, you have trend in your data, uptrend. Period 2 is going up and period 1 compared to period 1. Okay, so you have demand uptrend in period 2, but the fluctuation between period 1 and period 2, no change. Okay, it's constant. So in mathematical terms, you can write LTD2 greater than LTD1, or LTD2 equals LTD1 plus delta D. Okay, because LTD2 is higher than LTD1. So the delta D is the demand differential here. Sigma 2 equals to sigma 1, no change in the standard deviation. Okay, so when you put in the inventory formula here, you see LTD1 plus SS1 arrow 2, easy, no change. So from this formula settings here, we know LTD1 would be LTD2 minus delta D, so you can put here. Okay, now therefore inventory for period 1 that you for period 2 that you calculate in period 1 will be greater than LTD2 only and only if when safety stock for period 2 greater than delta D. That's what you can see here. Okay, so when SS1, this value, becomes greater than delta D, okay, then this value from left hand side will be greater than LTD2. Okay, so and you can try, you can put some numbers here, okay, and then you can verify this. It's not a very complicated mess. Okay, let's have some example here. week 1 through week 10 we have demand data. We have same hypothesis settings. Rejection limit is same. Put some numbers here. LTD1, LTD2, you get 150. LTD1, you get LTD2 400. Sigma 1, Sigma 2, same value using your data. So this means that fluctuation or demand fluctuation in period 1 and period 2, no change. Put in the safety stock formula, you get 73.55. You put in total inventory formula, you get total inventory 223. And you can see here that inventory number is lower than your demand for period 2. This means that your inventory won't be able to support the demand for period 2. Okay, not enough. So this means that we need to reject the null hypothesis and maintain that target inventory under demand system is insufficient to cover demand for period 2. In other words, so safety stock calculated using traditional method may not be enough to support demand differential in period 2. So this means that you need to bump up your safety stock. Okay. Now case number 4. Case number 4 says demand is going up, mean of demand is going up, standard deviation of demand is going up as well. So in other words, you have uptrend in period 2 compared to period 1. Okay, and also you have uptrend in demand fluctuation in period 2 compared to period 1. So mathematically you can write LTD2 greater than LTD1, and also sigma 2 greater than sigma 1. Okay, so LTD2 plus LTD1 plus delta D, and sigma 2 plus sigma 1 plus delta S. So demand differential sigma D, delta D, delta S is safety stock, standard deviation differential. Okay, so you put these mathematical equations in the total inventory formula. So LTD2 equals LTD1 plus delta D. So you can use instead of LTD1 here in this formula, you can put LTD2 minus delta D. That's what you put here. Then you move delta D to the left side. Okay, LTD2 here, and instead of safety stock, you can put the formula for safety stock. Okay, and so instead of sigma 1, you can also put sigma 2 minus delta S, because sigma 2 equals sigma 1 plus delta S, and you have this equation now. So this equation also tells you the same story. So your inventory for period 2 would be greater than LTD2 only and only if when you have the safety stock greater than your demand differential. Okay, and you can verify it using by putting some numbers here. Okay, it's easy math. I'm not gonna go over in detail of this one because that will just drag my time. So we are more interested in the results. Okay. Okay. Numerical example 4. You have some demand data. Hypothesis setting, no change. Rejection limit, same, no change. Put some numbers here. You get LTD1 105, LTD2 195, sigma 1 616. Sigma 2 10.1, and then you got safety stock 34.498, and put in the inventory formula, you get total inventory 139.498, which is still lower than the demand for period 2. Same finding as we see in case number 3. So meaning that your inventory is not enough to support demand for period 2. So this means you need to reject null hypothesis and maintain that your target inventory is not enough. So meaning that you need to have higher amount of safety stock to safeguard those situations for period 2. So traditional safety stock formula may not give you enough safety stock, okay, to support demand for period 2 at least. Okay, and if you have some more fluctuations, then you are screwed up. And if you have more demand upside in period 2, you are screwed up. Okay, So let's summarize our findings. As we have seen in case 1 and case 2, demand, there was no trend in the data, demand was stationary. So in those cases our traditional safety stock formula worked very well. But in case 3 and case 4, when we saw some demand uptrend, okay, we see that traditional safety stock formula may not give you enough inventory to support demand for that period. Okay, so this means that we need to be very careful when we are using traditional safety stock formula when we see the trend in the data, uptrend in the data. Okay, how about let's look at this exercise 1. That is for you. So what if the future demand, instead of going up, is going down, meaning that you have downtrend rather than uptrend? So will you still use traditional safety stock formula? How will it behave? And let's see what is your finding in this case. Okay, that is totally for you, and I will, in my next video, I will go over it as well. Wow, what is the downside of using this formula in that case? Okay, let's have some discussion on the forecast system. As we have seen in the beginning, forecast system uses forecast error instead of standard deviation of demand in the forecast in the safety stock formula. So we have assumed some demand, some forecast. Against those forecasts we have some forecast error that we calculated. Okay, so based on my experience, okay, I see that when forecast error from one week to another, from one period to another, is very close, very close, then your formula for under forecast system, safety stock formula under forecast system, may not be working good. Okay, so and let's validate my understanding by using a very simple example. Okay, so you have the data, you calculate standard deviation of demand using this data, that is 0.748, and we are using 99% customer service level. Against that we have Z score 2.326, and you put in this formula, your lead time is 5 weeks, and you get safety stock 3.8. In the inventory equation, you put these numbers, you have lead time demand for period 1 is 105, and safety stock is 3.890. okay, and you get total number for period 2 is 108. okay, and we have, so and your LTD2 was 195, as we have seen in case number 4. So we are using the same data for evaluating forecast system. Okay, meaning case number 4. So we are using case number 4 data in the forecast system example. So we see here LTD2 was 195. So this means that our inventory under forecast system is much lower than demand for period 2, meaning that it won't be able to support the demand for period 2. So for the safety stock we need to bump up, may not be good if we calculate using this method, right? Okay, exercise number 2. You can also try using forecast LTF1, meaning instead of lead time demand, try using lead time forecast for period 1 and see what difference do you feel, and how good or how bad safety stock formula behaves. Okay, we'll discuss. You do your stuff and see what is your finding, and I will show you my finding as well. Okay, so this ends today's session. In my next video I will discuss implications of these findings when we apply these methods in real world scenarios. That video will be more application based, so I would recommend you don't miss that video. And besides that, I will also be proposing some solutions to address these problems. So thanks for watching this video. See you in my next video.